Okay, so officially, good afternoon, everybody. This is the last of the 4 total lectures that I had said I was going to do in preparation for your foundation quiz. These will also serve as just resources, materials that you can use throughout the course when we are going through the offensive as well as the incident response portions of this class. This one we are going to be covering 4 forensic artifacts and some of the tools that can parse them. And I'm going to be walking through some spreadsheets that I have already created. So I'm going to start first by just showing you how you can create the triage package. We are using tools that were created by Eric Zimmerman. Some of you have already had me for network forensics and maybe even digital forensics. We have used these tools before, just to show that this is not just repeating for the sake of reusing the material. You can use these tools on many different types of investigations, whether this is a criminal investigation where you are, say, trying to find evidence against someone in a Ponzi scheme, or someone that's been accused of child exploitation contraband, or if you are investigating a network breach, because the artifacts that you're looking at contain the same information. It is just what you are looking for on them may differ depending upon the circumstances of the case or the information that you are given to start with. So for this particular type of evidence gathering, we start by collecting a triage package. Now, all of these tools, KAPE, as well as the 4 parsing tools I'm going to show you, were all created in .NET, which is another programming language. I've actually in the past taught another C2 platform called Covenant, which was also written in .NET. That's tools like C#, J#. You have to have something called the .NET framework installed on the computer in order for these tools to run. So when you use these, and I believe they automatically, they'll run on these computers, but just the same, if you're going to use them and for whatever reason they don't work, I have also included the .NET framework installation package in Brightspace. There's a download link in there along with my videos. Or maybe that was in my forensics class, but just the same, I could include it in here. But the first of these tools is called KAPE. It's Kroll something evidence parser. I don't remember the full acronym. But what it does is it pulls all the individual artifacts that people ordinarily look at during a forensic investigation, and it pulls them all in one aggregated folder. So we do not have to go searching for them. When you are doing this with one of these slower tools, they will look through all these, but what the power of these individual tools is you can actually focus on each individual artifact as opposed to waiting for the volume to be imaged. Part of the reason why Zimmerman created these was for the fact that regular computers, their media, their hard drives are getting larger and larger, which means that whenever you have to image a drive, it could be about a terabyte, sometimes more, and each one of those takes a long time to actually forensically image. So if you're in a larger department and you have a large load of cases, you could have a backlog that could last a long time, and it could be a long time before you even get to cases. By using these tools, you can actually focus on the evidence that you need and do it quickly, but you won't depend on these tools by themselves. In any forensic investigation, you have to validate what you find. So you would start with tools like these, and then when you actually get to your FTK imager created .dd or other raw image, you can actually find the material or the evidence and corroborate what you found. So tools like these give you the advantage of speed and the ability to focus on a single type of evidence, single type of artifact. I have only chosen 4 out of this. These are by no means all of the artifacts that people would be looking at, but some of these are, I would say, the most important artifacts that you would look at. So, namely, the 2 most important things you would look at in any investigation, whether it is for criminal or for a breach, network breach, would be log files and the master file table. Because every single thing you do on a computer is kept in some form of log file transaction. And I'm going to go through each of these when I get to them, but master file table records hold all information about every file and folder that appears on a disk. So with that being said, I'm going to show you now how to create a triage package, which is the starting point. So when you download KAPE, you will have to fill out the form giving your email address. You'll download a zip file, and on the inside you will have 2 executables. You'll have one which is for the graphical interface, which is what we're going to use, and this is just for the actual command line interface. So you will start this as an administrator. And by the way, the GUI version is just a graphic that sits on top of the command line, because as soon as you run this GUI, it brings up the graphic interface and just runs all the commands. So when you have the KAPE tool come up, it is going to be all grayed out like you see. So the first thing you'll check will be this Use Target Options checkbox. It means a lot of these other fields on the left side will become active. The first thing you're going to do is uncheck this flush checkbox. We do that because when we ran it before, it was not functioning correctly. I don't know the specific reason why, but we just uncheck the flush checkbox. Next, we go to Target Source, and we click the 3 dots button. You will select the C drive. For Target Destination, you will select the button with 3 dots. And this is where the output goes. We will just put it on the desktop. So now we have our target, and we have where it's going to be sent to. Next, you'll click the magnifying glass. And here you will type triage. And we will select KAPE triage. And the last thing is you will click execute. And then the command line will open, and it's just going to run all the commands. It should take maybe 2 minutes at most. And then it'll give you a little progress count at the upper left, as you can see right here, percentage-wise. We're not actually going to look at what I'm collecting right now. This is just to show how this particular application works. Last night, I already collected a triage package from a Windows 10 virtual machine that I attack regularly with Metasploit. So it's got a lot of data on it. So I will show you the output from that, but this is just actually capturing all of the artifacts from this gaming laptop that I'm using. And it's finished, so we click any key. We can go ahead and close the KAPE application. And as you can see, we had it go to the desktop. And what you get, which you can see right here, even though it's small, is it'll be a folder with C on it. Since we are taking artifacts just from the C drive. So I'll show you an enlarged view. Forensics. This is the triage package that I took from the Windows 10 computer that I triaged last night. You open it up, and it's going to give you these folders, which is most of the artifacts that we would be looking through, including the recycle bin. I'm not showing you the recycle bin parser, but that is one of the tools. Program data, users, and windows. So some artifacts are going to be user specific, because individual users will generate a lot of specific data. And then the others will be administrative tools that you can only find in the Windows folder. So the first tool I'm going to go over is the Amcache. The Amcache is part of the registry. And you can see this file right here is the Amcache.hve, or that's short for hive. Registry components are broken down into units called hives. So this is an individual file, and these are two other times I already ran the application, but this is the tool that we're using, a command line executable called Amcache parser. But we are doing this on the hive, and I'll show you how to actually run. So I will get inside Amcache. So to execute this program, we will start off with the executable name, Amcache parser. And since we are parsing an individual file, we will use the -f parameter. And then we will include the HVE file. And this parser provides, I believe, like 6 different CSV files. So the only other parameter we are going to include in here is a --CSV, and then we'll give it a name, which will be the name of the folder where the output is going to be. So I'll just call it Amcache stuff. And it didn't take very long, and you can see there's the output. I'll make this a little bigger. So it produces 1, 2, 3, 4, 5, 6 different outputs. And here's some of the other things that are stored in this particular registry hive. You have device plug-and-play devices, binary files, driver information, shortcuts, and this is the one really that relates to us. We're not really going to get much information out of these others, but we're going to look at one called this Amcache unassociated file entries. I've already opened this, so Amcache. So I've just highlighted a few items that we could look at. Whenever you open one of these output files that's created by the parser tool, it's usually going to be kind of messy. It's going to be all jumbled together. So one thing you do to actually better make use of it is you can actually delete some of the columns that you know you're not going to use. You can increase the size of the font, maybe center some of them so you can actually read. But from unassociated files, which you can see over here, in Windows, many files that we use often have some kind of parent-child relationship with another application. It's like something Microsoft or Windows, Adobe Acrobat. They will usually relate back in some way to them. When you see an unassociated file, it is not always this way, but it can be suspicious when it does not have a parent association of some kind. As you can see, when I have identified, these are two payloads that I created and then used on this Windows 10 machine. As you can see, there is no product name that it's associated with, which is why that's blank. So what we would get from this would be they have a timestamp of when it was last used, they have a hash value for the application, and you have the file extension, so you know it's an executable. But this information is similar to what we would get from prefetch files. Prefetch files are another folder within Windows that trace show us how often certain executables have been run, when they were installed, how many times they've been run. But they are not often, that information is not tracked sometimes by default. But all this information that I'm showing you here is tracked within a registry, the Amcache registry hive. So this is one place that you might look if you are searching for malware. Remember I said yes?
If you wanted it to try and blend in more like by having a product name, is that something you would have to do in the first payload or later?
Usually if you were trying to make it blend in, you would probably try and add metadata to it. But this was not associated. Usually it would be spawned by another product. Like if you were opening a Windows, like a spreadsheet or some other, and sometimes these applications will spawn additional objects. See, since this was not spawned by another parent object, it does not have an association, which is why that's going to be blank, and it's going to stand out a bit more. It's like any C++ program, portable executable that you create and you move over, it's going to have that unassociated title to it. But yeah, they will sometimes give it names that try and sound routine, or they might try and stuff additional metadata that to probably the trained eye, it's probably not really going to fool very many people, but just by the nature of the fact that it was unassociated means it would deserve more scrutiny. So this is the first of the artifacts that we're going to look at, but whenever you look at data like this, it comes in a spreadsheet. It gives you the ability to actually sort things in a way that is probably more meaningful for us. That's why I said when you first get it, you need to kind of neaten it up so you can actually look through it. All of the artifacts we're looking at, 3 out of the 4, are going to be in spreadsheets. But the log files we're going to view in a graphical interface called Timeline Explorer. There was another, you can actually view the master file table through that same tool. But I'm going to show you the data in its spreadsheet, because you can still use the CSV file to actually search for the information that you need. So this is the Amcache. Second tool, or second artifact rather, is going to be the master file table. The master file table, as I already mentioned at the beginning of this lecture, is a database that comes with Windows media that has Windows as its operating system. Windows has NTFS, or the New Technology File System, as its file system. It has come with that since, I believe, 1994, when it was first introduced with Windows NT. As part of that, the master file table comes with NTFS. And I believe Windows 12 is coming out this summer, and that is also going to be coming with a master file table. The MFT was not designed with forensics in mind. However, it includes a wealth of information that does help us forensically. So what I'm going to show you is how to run the tool, and then how best to search for information within the master file table. So Okay, so this tool that we're using here is the mftecmd.exe. And again, this is a single file object that we are parsing, so we will use the -f parameter, and then we will put $MFT, which is a copy of the master file table. We cannot, as regular users, simply grab a copy of the master file table while you're on the computer. Since Windows is using it, it will not allow us to grab it, which is why we have to use a forensic tool like KAPE, or I believe FTK Imager will also copy the master file table for you. But since we are parsing it with this tool, you have to use the -f parameter, and we also have to provide it with a folder name and a CSV name. Let's see. Oops. And this will take a minute as it's parsing everything, but this is one of the ones that probably takes a little bit longer than the other tools. I think the one that takes the longest is going to be the log files, because that's about a two-step process for the parser to get through. And it has finished. So when it's done, you can see parsed MFT, parsed. So that's the parsed master file table, but I already have a spreadsheet open. I actually already deleted a few of the columns because there are many, many columns in this output. I don't know if this tool actually includes all of the fields that come with the master file table, but it comes with several. And actually, since the master file table has been around since the 90s, there's some technology associated with it that we no longer use. But there are fields in it that still exist. They're just not used any longer. Things like cylinders, heads, and sectors, because those were associated with magnetic disks. They will still have them in there. They may even have some values in there. But those are dummy values that we're not really using, because even though some machines may have some magnetic disks, those are usually hybrid, and most machines and laptops now are going to, modern ones anyway, are going to come with flash-based memory. So the first field we have in here, after I got rid of some of the other superfluous ones, this in use tag. This is the flag that's in, I think, one of the first three rows of the MFT record. It's usually a 01 or a 00 if it is a file. And then 01, which is true just in binary, means that the file is in use, meaning it still exists, on the disk. If it is a 00 or false, it has been deleted. And if it is a 03, that is a folder that has been deleted. I think that's a folder that's in use. A 02 is a folder that has been deleted. So this will tell you one thing if the file that you're looking at has been deleted. So as a use case example, you may have come across a malware payload that was programmed to delete itself. Some things will actually do their dirty work, maybe make its connection, offload its files, and then it will be programmed to delete itself. And then you won't be able to actually find evidence that the payload was actually sent in some places. However, you can see that the file first appeared in the master file table. So you won't probably see that it was, well, you would actually probably see that it was deleted, and you could see when it first appeared. But the ways to sort this are probably best by file name, by extension, or by created date. And I'll talk first about the created date. This date that you see here, I've highlighted in green, I converted because they were similar to these other dates. These are in, currently, these other fields, these timestamps, are in a form that's only understandable by the file system, by the CPU. If you want to actually be able to put it in human readable form, you have to actually go, into Excel and change it to, date time. It's one of the reasons why it's good to actually put it in Excel, because you can reformat some of these columns. So, say for example, the information that you received in your case dealt with, all right, the bad stuff started happening 2 days ago. And while they are still collecting anecdotal evidence from people, you get the master file table records and you sort them by date. And then you go to the most recent ones first, and then you can go to the date when the bad things started happening, and you isolate the window of time you're dealing with from that date, to the present. Or if they've isolated the machine, probably a couple days. So within that window of time that you have isolated, in your CSV file, you can take a look at what files were created and maybe what was deleted. Maybe if you found some unusual binary, a .bin file that had a mundane, routine name on it, but it does not relate back to anything else that you know of, in the organization. That's something that you would probably scrutinize a little bit more. Another way you could approach this would be by sorting things by file extension. Maybe you know a little bit more something about the attack and you think that it is an executable file. So you could sort the extension, alphabetically, and just go through all of the executables, maybe within the time range that you think it happened, and then look at all the executable files. You can eliminate the ones that it obviously is not, and then look at the ones that look suspicious. See, what the tools like these do is they help you make the haystack that is digital forensics smaller, because really the art and science of forensics is really the art of making gigantic volumes of data smaller in more efficient ways. So there's only two ways you can look for something, because whatever you're doing, whether it's looking for evidence of a crime that was committed, or if it was like a breach and you're looking for evidence that someone actually broke in, those are little trace pieces of evidence that exist in thousands, maybe millions of records. So there's only two ways you can find that kind of information. It's either make the haystack smaller, or you find a better way of actually pinpointing the needle. So that's where creativity sometimes comes in with the tools that we use. And oftentimes when we get these expensive forensics tools, Encase, FTK, Magnet, even with all their really fancy looking tables, oftentimes it still comes down to one person scrolling through a number of records. Unless you know what it is more exactly that you're looking for. So you can make the haystack smaller by knowing more about what's exactly in the computer. That way you can throw out a lot of this stuff. Or you can say, all right, I know this needle is an executable, and it has this type of name, and it's about this size. So then you can basically throw away a lot of the other stuff. Because if you get to know this kind of stuff well enough, that's why some people could probably write their own tools to actually look for this, because they've found a more efficient, maybe faster way of making the haystack smaller and better identifying that one little trace piece of evidence you're looking for. So again, you can either, or if you know something, maybe you're familiar with the attacker group. It's Cozy Bear or Fancy Bear. And when you read the profile on them, you know that they use a specific type of payload. So you do a search, alphabetical search for that type of execute, and you know it's going to be an executable or a binary, and it usually has the same name. You can sort by name. So anyone can come up with their own efficient way of looking, but the three most popular ways of probably searching through a master file table are going to be file name, extension, and timestamp. The next thing we're going to look over is going to be the System Resource Usage Monitor. So anyone in here who uses Windows will know what the System Resource Usage Monitor is, because whenever you do a Control-Alt-Delete, this other window pops up with a bunch of tabs on it. One of those tabs, excuse me, has all the little, it looks like a ticker it has an analog signal on it that shows the performance of your GPU or your CPU. So if you're playing a game which is very graphics intensive, and then you pull that up and look at the GPU, it may be causing that thing to go to the ceiling for a long period of time. Or you can click another tab, and that will show you all the running services or all the running processes that are running in the background. This is all stored in a database. And that is where's it on here? It's called the srudb.dat, which I'm highlighting right here. And it holds a concrete, finite amount of information. I don't remember exactly how many days it covers, but once you have filled it up, it does not, keep expanding. It basically just goes back to the beginning and then starts writing over again. So it holds a certain period of time in this database file. So what can you find in this? Well, running processes include things like browsers, or if they brought up PowerShell, if they brought up a command prompt, if they opened a special application that they installed and it's open on their desktop, that will be represented in the srudb. So to get information from the srudb, I will go back. We will run the srum ecmd.exe. And this is going to be, again, a single file. It is a .db file. So we will use the -f parameter, a .dat file. Copy. And I believe this one only takes as a parameter the name of a folder where it's going to be putting all the output. So we put CSV SRUM stuff. And that one's rather quick. So it saves it right there, and this actually has 7 folders of output that it gives us. And this has a lot of information, much of which is not really going to be much good to us. It gives energy usage, I opened up some of those, and it does not really have much information that we could really read and make use of. So the only thing that we can really use, to some extent, they have push notices, which are those little messages that pop up on your screen. It may say something like something was installed, or time to empty your recycle bin, or something else that was, told, like there was appearing on the screen to remind you of something. But the only thing we're going to use is the app timeline. Let's see. SRUM. Okay, and I've marked, I think, a few things on here. But you can see on this, I sorted these alphabetically. So you're going to see all of the similar programs are grouped together. So this is when somebody ran a command prompt and entered commands manually. A lot of these are things that are running in the background, but I think they have curl. Remember, we used curl to actually transfer files from our Kali Linux to our attacker machine, or to our victim machine. So curl was run on here. So if an attacker got on the machine and ran additional commands, you could actually probably find some of them represented here. And as you can see, Explorer. Explorer, of course, is that window that you open when you want to see, like this. This is Explorer. So whenever someone opened this up to take a look at what was inside a particular directory, they opened Explorer. So Explorer was opened quite frequently on here. And Firefox. So they had Firefox open. And a lot of these, again, if you were knowledgeable enough of the environment, you could probably throw out a lot of these other processes that are running in the background, but you could focus on things like the browsers that were open, or keylogger, like I got here. So two things we noticed right off the bat. Someone ran a curl command to transfer a file, and a keylogger was running. So between this and the Amcache directory, we are able to spot not only payloads, but other processes like a keylogger or a file transfer program. So one last thing, and since we only got about 5 minutes, I'm not going to run the program itself, but I'm going to run Timeline Explorer. This is a tool that will actually facilitate a very large spreadsheet data sets that come back. Like in this case, we are going to show you the log files, because what the log file parser does is it takes tens of thousands of log files of different types, and it aggregates them all into one folder. And then when you run the log file parser, it puts everything into one spreadsheet. Now, you're not going to easily be able to open that spreadsheet, because something that big is going to take several minutes to actually open, and you're not going to easily be able to sort things when it's that big. But with a tool like Timeline Explorer, it actually gives you a slicker interface that's easier to read. So I'll run this as administrator. And then we will go open a parsed log. So this is the result of running the log parser. It's put everything in a larger CSV file. And then we open it in Timeline Explorer. And this is already, so all the records just by default are going to look like this. So it's going to be the same as if you were just opening up a spreadsheet. But one thing you can do, which actually will help you regroup, resort, and index these, depending on the information that you get, you may wish to approach the information in a different way in order to reduce the size of the haystack, so to speak. And to do that, for example, you may use these tags or tabs that are on the top. These are all columns. And what this program allows us to do is to sort. Map description is a new field that the parser provides, and it's a type that it gives to each of the event logs. So we can sort by event log type. So we can actually just click on it, drag it to the top, and all of the thousands of records are going to be sorted by the type of event log record that it is. So if you further wish to sort and regroup this, you can probably do it by time created. And you can stack them. So if you want to look through all user logon event log types, it will go through and sort them by date. Or if you want to do it backwards, you can do it by date and then by type. So, yes?
Could the people who are going to MillLab head out?
Yeah, go ahead. If you got to go to MillLab, go ahead. So, this is a way you can actually use this tool as well for master file table, because this gives you a way of sorting extremely large amounts of data in a way that helps you find the information you're looking for a lot more easy. So that's the last of the artifacts I'm going over, so I'm going to stop the recording here.